Yes, sir.
Yes, we can hear you, Mr. Siva. Okay, Mr. Siva. Am I audible? Can you hear me?
Yes, sir.
Yeah. Okay. Okay. Yeah. Yeah. Good morning to you all, and I'm really honored, to have you all today. This is the second day. Most of you, you were with us, yesterday as well, and today. And yesterday I did the presentation. I gave, the overall account of the Arduino, and I did a few examples as well. And today the same workshop is continuing, and it will be presented by the most respected Dr. Priyanka. She's joining us now. I think she's available. I was chatting with her earlier on. Yeah. So if you could, yeah, just start. I don't want to take much of your time. Thank you very much. And thanks for everyone who is attending today.
Thank you, sir. It's my immense pleasure to participate in this session as a keynote speaker. First of all, I would like to thank Izrin sir for giving me this opportunity, and further and extends my thanks to Vural sir, Dean of Faculty of Engineering, for giving me a continuous support as a collaborative work with your Tishk International University. Once again, it's my privilege to have a collaborative work with you all. And Yesirin sir, thank you for this wonderful moment, for giving me to take over the session of Arduino programming with motor control applications. So let me start my presentation, sir.
Um, yes, sure, yes.
Okay,
Okay,
sir.
yeah.
Okay,
Okay,
sir.
thank you very
Okay.
much.
Thank you, sir. Thank you. So is this presentation visible to everyone?
Yes, ma'am.
Oh, okay. In the second session of International Workshop on Arduino Fundamentals and Coding online through online mode, I'm going to take over the session of how to program using Arduino, mainly for motor control applications. So before going to explain you the programming, I would like to tell you about the general characteristics of motors and its types. So we shall start with that. Normally, what is motor? Motor means nothing. It is a device which will be used as an output to convert electrical energy into mechanical energy. Electrical energy into mechanical energy means you will be giving the power supply as the input source. Through electric motors, you will be having different components. It will start to rotate, so you will be getting a mechanical energy at the output side. Normally, the electrical motor is the basic function to convert electrical energy into mechanical energy. So how this electrical energy is converted into mechanical energy means it's simply based on Faraday's law. Faraday's laws means whatever the motor, it may be a traditional or maybe an advanced or it may be a special types of motors, there will be only few components which will be mandatory in all the motors. One will be a rotating part, another will be stationary part. Normally, the stationary part will be the magnet having two poles, north and south. So between this magnetic poles of north and south, the conductor with the current carrying capacity will be placed between this magnetic poles. So from north pole to south pole, always you will be having something, some sort of magnetic lines. Through the conductor, by passing current, it will start to cut that magnetic lines of force. So how much amount of magnetic lines of force is cutted by the conductor with current carrying capability, it will generate an EMF. This will be called as an Faraday's law. In simple sentence, if let me explain you means, whenever a current carrying conductor is placed in a magnetic field will be generated by the magnet of north and south pole. A EMF will be induced. This is the simple basic principle of Faraday's law. So based on this Faraday's law only, our electric motor is working. So whatever may be the person, if you have to think or view the schematic of electric motor, there will be a two things: stationary part and rotating part. The rotating part will be moving inside this stationary part of magnet. So it will be generating some EMF, so that your shaft of your motor it start to rotate, that is from 0 degree to 360 degree. Likewise, you will be getting continuous rotation. So we are getting a conversion of electrical energy into mechanical energy. Ma'am, this electrical motor will be operated by what type of power supply? Normally, we are having two types of power sources in nature. One is direct current, another one will be an alternating current like AC source and DC source. The electric motors having the capability to work under the supplies of DC and AC, both the characteristics. Okay. So the next presentation is showing the visible schematic view of how your motor works. So this rectangular shape will be the okay, yeah, conductor with the current supply. So this north and south pole will be the magnet generating this magnetic field. So when through the electric current from this power supply, whenever the power supply is given to this two terminal of this conductor. Okay, in order to oppose this magnetic force, the electric force will be generated. So your this rectangular coil, it starts to rotate. So based on this rotation, we are getting a mechanical energy at the output side. So this is the most basic working principle of the motor with the schematic. So whenever you give the current to some conductor, okay, your conductor, it will start to move in opposite direction to the current flow, because the conductor is flowing in one direction of this conductor. But in the basic principle, in opposite to that current supply, your motor starts to give an opposition force to that current supply, so that the rotation of this rectangular coil takes place. This is the outline view of working principle of motor, which we are getting influenced in present day. So in all categories of special types of motors. Okay, so general parts of the electric motor will be, you will be having copper wire, magnetic poles, split rings. Split rings means, since your conductor is rotating continuously inside your motor, it should be connected to the load which is present at the external side. So some device should be placed at the end of this conductor to get the power generated by this rectangular coil in order to supply to the load. For this purpose, the split rings will be used. Okay. So next one will be brushes. Normally, the brushes will be used to connect the motor shaft with the external devices. Next one will be the battery. These are the essential categories of components which will be mandatory in the inside the electric motors. Okay. So if now we have understood what is meant by motor, in what principle the motor starts to work, and what are the components present in the electric motors. So next type will be the types of motors. So already I have told you, our motor have the capability to work with two types of power supplies. One will be our DC, direct current. The next one will be AC, electric current. So based on this power supply mode, our motors has been classified into different types. So this is the tree diagram of this classification. So first, initially the motors are classified into DC motors, AC motors. In AC motors, you have different types like synchronous motors and induction motors. In induction motors, because AC means you will be having three-phase power supplies, right? So in induction motors, based on the phase wise performance, you are classifying it as one phase induction motor and three phase induction motor. Special motors means moreover, the DC motors with the different characteristics will come under the influence of this special motor types. Okay, in next slide, I will show you the elaborated classification of all these types of motors. So this is the entire tree structure diagram of the motor types classification. This is to show you in what are the categories these electric motors through different power supplies is getting varied. If I go with AC motor, that is, if it is works with an AC power supply, that will be comes under linear, synchronous, induction. In induction, I have told you single phase, three phase. In synchronous motors, you will be having two types, reluctance and hysteresis. Next one, in DC motors, you will be having three different types. That is series, compound and shunt under self-excited category. Next one will be separately excited category. All these characterizations is getting viewed based on the perspective of how you are giving or actuating the power supply to the rotor and stator part. I have told you we will be calling other, because in motor I have told you you will be having two regions. One will be stationary region, other will be rotating region. Rotating region we will be calling it as rotor. Stationary region we will be calling it as stator. These motors classifications, that is the second part. This violet color classifications are based on how you are giving or inducing the power in stator part. So based on that characteristics, you are having these types of classification like series, compound and shunt. Means in what way, in what manner you have been used your power supply to power up the stator and rotor. So based on this only we are having this much classification. You don't think that it is like a vast area like that. It's only the in most fundamental thing how you are making your connections and power boosters. So based on that classification only we are having these types. In special types of motors you will be having stepper motor, brushless motor, hysteresis motor, reluctant motors and universal motors. Why I have been shown these elaborated types of motors in today's class, I'm going to um, like give the overview of three main types of motors. One will be DC motors, like a general category of DC motor, how it can be used and how it can be programmed using Arduino. And second type of motor is servo motor, because the servo motor means like it is a like closed loop motor. This is the most special characteristic motor which will be preferred in industrial applications. Next one will be third one. I have told you DC motor, servo motor. Third one will be stepper motor. Stepper motor means where it will be mainly used. Means the stepper motor mainly used in toys manufacturing and small preferred integrated circuit application like hand wrist watches, toys. In a small robotic arms we will be using stepper motor. So these three motors characteristics and how we are going to program these motors for motion control applications, those things will be covered in today's session. So I have now explained you what is motor and the principle of working and its components and its types, and among this diverse varieties of motors, the three important motors which we are preferring in day-to-day activities with application oriented things, I have taken DC motor, stepper motor and servo motor. Okay, now we shall go with our first topic as DC motor. So DC motor means it will be under the influence of magnetic field. The current in the conductor will move in two directions, clockwise and anti-clockwise. So based on the current flow in clockwise direction, your mechanical shaft of the motor will rotate in clockwise direction. When the polarity, that is the current direction, is changed in your conductor, automatically your motor shaft will start to rotate in anti-clockwise direction. So those things we will see in simulation, how it's rotated clockwise and anti-clockwise. In DC motor, what are the main components means, I have told you in motor we will be having two components like stationary part and the rotating part. Here the rotating part we will be calling it as armature, and the stationary part we are calling it as a field winding. So by giving power supply to this field winding, how our armature parts getting rotated is the thing we are going to see. So normally in field winding you will be having many coils that will be covered by the copper wire wounded in series manner. So by energizing these coil, it start to act as a magnet. So what reaction it takes place means, you will be knowing that like poles repel, opposite poles attracts. So when the coil is that is the field winding of the coils gets energized, means it start to give some type of magnetic force. If it is in same force as like north pole magnet and south pole magnet, likewise the repelling and attraction force makes to have a rotation motion. So finally your motor tends to rotate in either clockwise or anti-clockwise. So if we give continuous power supply to this field winding, north pole gets repelled, like north pole and south pole gets attracted. So like this is the most important thing happening. We are making a conductor to act as a magnet with pulses. So default we have a north pole and south pole magnet inside the motor as a stationary part. So this is the based on the attraction repulsion force, your shaft starts to rotate. That is that it will be pushed by the magnet's poles. So so from 0 degree to 360 degree you will be having a push outs. That push out will be given by the field winding with the power supply. So this is the DC motor and how it works. This is the principle. So now I would like to stop this presentation and let me explain you how to use our program using Arduino for this DC motor. After completing the simulation part of DC motor, we shall go ahead with servo motor. Okay. Now, okay. For the simulation purpose, I am going to use a Linker CAD online simulation platform. So this you can be Tinkercad. This you can be used for your online simulation purpose. So you can log in with your Gmail ID, like institutional or your personal mail ID. You can log in out and you can see the options over here, 3D design circuits and everything. Now you can in this option in the left hand side, I'm going to choose circuits. So in the circuits, I am going to use this create new circuit. So initially, let me show you. So here I'm just going to take this Arduino. In Arduino, you will be having power supplies, analog input pins and digital pins. Here you will be having some approximate symbol over this mark because these are Arduino's inbuilt pulse width modulated pins. So this pin you can use for if you want to use your devices for running pulse width modulated signal, you can use this. So before that, I would like to show you this one. So first we have taken Arduino, next DC motor. Okay. So I am going to connect this DC motor. Now what I am going to do means I am going to connect this ground pin to this Arduino's ground pin. You can directly give a power 5 volt power supply to this terminal, but I am going to take my digital pin, second pin, which can give a digital pulse signal with the maximum magnitude of 5 volt because my Arduino have the capability to give a power supply up to the maximum range of 5 volt. So my second pin will able to give pulse width signals with a maximum magnitude of 5 volt. So this pin I'm going to connect over here. So now I am going to use text for coding. Okay. I'm going to continue with this. So this is the thing. Here, void setup means in the coding, you can see void setup. Why void setup? This part of this program for what purpose it has been used means this is the part, the pins for configuring purpose. What are the pins you have taken? The pins can be identified by this number. In coding, you are mentioning this numerical value. Your Arduino controller, by when you have been embedded the C++ code into your Arduino, it will understand properly because whatever may be the program, first initially it will analyze what are the pins are configured and what are the pins are configured as input and output. Now I have fixed only, I have taken only second pin as output to run my DC motor, right? Void loop means if you have been dumped this program into your microcontroller, if it sees void loop, what are the program you have written over here will be continuously run by your Arduino until your power supply to this Arduino is cut off. So until it is on, if you are giving the program using void loop, it will start to do it continuously. Now, because I have written digital input pin, second pin as an output to run my DC motor. So, see, I'm going to give this as 2. I'm going to give this as 2. I'm going to make this pin high for rotation, and after for some time I'm going to stop this motor. 1000 millisecond means for 1 second it will run, and for 1 second it will be in off state. So I have completed my coding. So we will, if you click this code, it will get hide. It will hide the program or the codes which you have been typed over here. Now I'm going to start my simulation. It's getting initializing. See, the motor is running for 1 second and it is getting off for 1 second, because for I'm giving a time delay as 1000 milliseconds. 1000 millisecond means 1 second. So it rotates for 1 second. So in this second one, I am going to use, okay, inbuilt pulse width modulated pin for connecting my DC motor, and we will see how it works. Okay, because in fourth pin you have been given to the ground. Now what I am going to do means, in third pin, okay, third pin I'm going to connect over here. So see, the positive terminal is given to 5-volt power supply of second digital output pin, and -3 inbuilt pulse width modulated pin of Arduino is connected to my negative terminal of my battery. Okay, this is the coding. I'm going to take it out. In quotes, I'm going to paste it. So see, in void setup, I'm going to, because in void setup, I have told you this part of this coding is used for configuring the pins which you are going to use as input and output. I am going to use second pin and third pin as output for my DC motor running purpose. Okay, what I'm going to do means, for clockwise rotation, I'm going to give second pin as high, simultaneously third pin as low, for 5000 millisecond time delay. After clockwise rotation, immediately for anti-clockwise rotation, I am going to configure my second output pin as low and third output pin as high. Just only I am toggling my two states of the output pin simultaneously. By changing these two pins with a time delay of 5000 millisecond means 5 seconds, my motor will rotate in clockwise once for 5 seconds and anti-clockwise in 5 seconds. So we shall see that. Okay, so I will hide my quotes. Let me start my, so see, my motor is running. So now you can see that negative sign. So for 5 seconds it rotates in clockwise, and next 5 seconds it starts to rotate in anti-clockwise. The simply what I have given means, I have given one pulse signal. Excuse me. Okay. What I have done means, I have used two pins. Okay, I have continuous. What I'm going to do means, I'm going to give two power supply to my DC motor. In that, I'm going to make one signal in high state and other output pin as off state for particular time period. After a certain time delay, I am going to make, I'm going to toggle means I'm going to change the states of two output pins which I have been fixed as high and low. So by doing this, what my motor understand means, it's try to rotate in clockwise and it's tries to rotate in anti-clockwise. This is the thing. Okay, next, these are the simple application, because I would try to show you how initially motor works by connecting with Arduino. and how you can make your motor to run in clockwise and anti-clockwise. Next interesting thing is I'm going to use PIR sensor. Okay. Normally, DC motor will be used for object detection control because using PIR sensor. PIR sensor means passive infrared sensor. This sensor will give output whenever an object comes in front of it. So, whenever an object is sensed by this PIR sensor, your DC motor interfaced with your Arduino will run. Let me see that. Okay, you guys, I think so it will be interesting. Let me stop this stimulation. Okay, so first I have to, what are the things we are in required for this means, first thing we have to take PIR sensor. So this is the PIR sensor I'm going to take, and next time Arduino is already present, DC motor, and next one will be my battery, 9-volt battery. Okay, and so next I'm going to use a breadboard because it's not an easy task to connect all these things. So what I'm going to do means, okay, so for, because we are going to connect an DC motor, normally in real-time application you cannot directly connect DC motor with Arduino. You will be using line driver, or you will be using diode, or you will be using transistor, because in order to control reverse current flow, okay, you will be using some interface devices in the connection between interface between your Arduino and DC motor. Here I am going to use NMOS. So NMOS transistor I'm going to fit in over here. Okay, now we will connect this 9th signal pin of PIR sensor to my 9th pin. Okay, this is that is the inbuilt pin of pulse width modulated signal pin of Arduino is connected with the supply pin of my PIR sensor. Now the power supply is connected. Now let me take here 5-volt power supply to this breadboard. Okay, let me give this color as red color power supply. Now I am going to give a ground signal over here. This will be, I will give this color as black in order to get so what I need is I should give the power supply. So I will connect it over here. Next, ground pin, I will connect it over here. So next, what I'm going to do means I am going to connect this negative of this battery to the breadboard another terminal, and positive terminal of the battery to the next terminal. Next we will change the color of positive in order to get clear view. Now what I'm going to do next means, now this motor positive will be connected with the positive terminal where your battery's positive is connected. Okay, in NMOS you will be having 3 channels: gate, drain, and the source. Okay, now normally we will connect source to the ground. Okay, I'm connecting it to the ground. So ground means we will mark this as black. Next, the NMOS drain will be connected to the upper part of the breadboard, because see, in more, see, we have to, whatever the system we are designing, it should be form a closed path. Everything now we have been connected, but still DC motor negative terminal is left free. It is not interfaced with any other terminal. What I'm going to do means I am going to take this terminal and connect with this drain of my NMOS. Okay. And then gate pin of NMOS will be connected with my second digital pin of my Arduino. Okay. So see here PIR sensors positive and negative power supply is given accordingly, and supply pin of this is the signal pin of PIR is connected to my pulse width modulated pin of Arduino output, that is digital output pin. My battery is given over here. Battery positive is connected with my motor positive terminal, and negative terminal is connected with my NMOS in order to prevent reverse current influence of Arduino with the DC motor. Now what I'm going to do means I have completed the interfacing purpose, and I have made a closed path because everything has been a closed form. Now I have to take my code. This is my code. So let me explain you that. See, PAR pin 9th pin. See, 9th pin is connected. Arduino 9th digital output pin is connected with the PAR. So PAR pin I am going to configure as a constant integer 9th pin. And motor pin is connected to the second pin because see, NMOS pin is connected with the second pin of Arduino. In the drain pin is connected with the motor to make a closed path. So motor pin is connected to the second pin. Let me highlight this with orange. Okay. This one with also an orange color. So you will get a clear idea. That is what are the pins I have? 2 and 9. That is one is PIR pin and motor pin. So I am going to write a program, that is void setup. What I'm going to run, what I'm going to code means, okay, normally this PIR pin will be serving as an input. The concept is whenever my PIR pin sends an object, it will give an input signal to an Arduino. And from that input signal to the Arduino, my output for my that is output of my DC motor will be enabled. It will start to run. So when my motor output will get it to on state means when PIR sends an object, unless otherwise it does not sense any object, your motor will not run, because whenever it senses an object only, it will allow the Arduino to run the DC motor through this NMOS transistor. Okay, that is the concept. So I am going to configure my PIR pin, PIR sensor pin as input, motor pin as output. The digital switch case, what I'm going to run means whenever my PIR pin is high state, okay, my motor pin will get a signal, it will generate an output. Otherwise, my motor pin will be in low state. So my whole operation is based on this PIR motion detection. So if it is sense an object means it will generate a high signal. So whenever it generates high signal, my motor will go to a high set level and it gives an output. If it is in low state means it does not sense any motion, that is any object, it will give you an output status low, that is 0. So my motor also will be in 0 state. 0 statement, it will does not start to run unless otherwise it receives a high state. So this is the thing, this is the code I have explained you, like switch state case I have been used. If it is high, my motor will run, otherwise it will be in low, that is off state. So let me, the code part has been completed. We shall start this simulation to see it. See, my motor is in 0 RPM, right? So my One sec, let me see it. So drain pin is given over here. Okay. So one thing I think I should connect one power supply over here. This to this. So positive power supply, positive power supply. We shall start our simulation. So see, our motor runs. So now no motion. That is, the object has not been detected. My motor is in off condition. Okay. Now I'm going to give an, that is, some object is going to come near the PIR sensor. So object motion is detected. My motor starts to run. So unless the object is present, my motor will start to run. And if the object is not detected, my motor will not run. So see, so based on my detection, my motor runs. Can you visualize it? You can see the RPM rate. Is it clear? Can you visualize it? So like this one. So like this only the PIR sensor is used to detect the object detection with DC motor. So you can control the motion of the DC motor using PIR sensor with object detection. Okay. So this is the perspective how to how to connect Arduino with the DC motor to visualize or to simulate the rotation of motor. Second thing I have shown you by connecting two pins of Arduino how you can make your motor to run in clockwise and anti-clockwise. In third part I have shown you how PIR sensor is used for motion detection with DC motor, and based on the object detection how your motor is showing its rotation. Next thing I will explain you servo motor. Servo motor, ma'am, what is the difference between DC motor and servo motor means? Okay, here I am going to show how the AC power supplied servo motor will be working like that. Okay, normally in servo motor means what it will do means it will be having feedback line. Feedback means in other types of special types of motor, AC or DC types, you will not have a inbuilt feedback concept, but in servo motor you will be having feedback concept. Ma'am, what is mean by feedback? Feedback means you will be giving, this is my output, my motor should be in this position, like that you will be fixing your motor to be in particular place. Okay, for that what your motor will do means inbuilt it have some control circuit. It will make, it will compare the given data, and currently now motor is in what condition. So by making a comparison between this, it will adjust my input data. So in order to get my target output value, it will make a corresponding change in the input to get the desired output, because currently your motor will not be in a position what you have been fixed, but you just want your motor to run and to be in a fixed target place. For that your motor will have a inbuilt control circuit which will make a comparison between the input and current output state. For that, it will compare and it will generate an error signal. So next time what it will do means it will check that error signal. If your error becomes 0 means your motor has attained its target position, your motor will stop its rotation. Unless otherwise your motor has not reached its target position means you will have an error value, and your control circuit will try to work to make your error value to be 0. Once your error value has reached 0 means your motor has reached its target position and your motor will stop its rotation, because your control circuit will tell its motor you have reached your target position, so no more movement is needed and your error signal has been nullified. Nullified means it has reached a 0 value. 0 means your input gets matched with your output and your target position has been reached. This is the basic servo motor concept. Normally, basically how it will be, servo motor will be controlled means by using pulse width modulation principle. Pulse width modulation principle means you will be giving continuous signal in the form of digital pulse. So based on this digital pulse on period, off period, your servo motor will make its rotation. In order to adjust the performance or rotation of servo motor, we will be using potentiometer, variable resistor. By adjusting the potentiometer, your servo motor rotation angle can be controlled. Okay. So if I would like to tell in detail means how it will be. Okay. Normally, in the first paragraph, in the first diagram, you can see if your arrow mark is upon this right side means it is in 0 position, that is 0 degree. This is 90 degree and this is 180 degree. So by adjusting you the potentiometer, you interface your servo motor, this rotation can be varied. This is one type, okay? The other type is, if you want your servo motor to work with the digital pulse, I have told you pulse with modulated signal. Pulse with modulated signal means likewise you will be giving continuous signal in the form of digital pulses. That is, this is the on period. 1 millisecond is indicator, right? This is considered as on period and remaining this entire space is considered as an off period. My servo motor have the total time period of 20 millisecond means for 1 millisecond it will be in on state and remaining 19 millisecond it will be in off state. Okay, so let me show you that. So now you understand, now you have been understood the concept of servo motor, how it can be regulated. Okay, let you show you this. First of all, I would remove all those stuffs. So now what I'm going to do means I'm going to take my Arduino. First, initially simply a servo motor. I will show you how, okay, to show like what are the pins. So now I have taken this servo motor. In servo motor, you will be having 3 terminals. In this 3 terminals, the ground terminal will be connected with the ground terminal of my Arduino. This power terminal is about to connect with my 5 volt. And this signal pin is connected with my pulse width modulated signal. Okay. I'm going to write a code for it. So I'm going to take a text. Okay. Continue. So since I have been used 9th pin as my output, okay, 9th pin, okay, I'm going to configure 9th pin as my output, 9th pin, 9th pin. Now I will show you how the on period, off period, because I have shown you the digital pulse steps on time and off time, how it have its impact on servo motor functioning. Now I am going to give a time delay of 1000 millisecond, 1 millisecond. Okay, in my on period is 1 millisecond, my off period is 1 millisecond. That is equal percentage. That is 50% duty cycle. The 50% duty cycle means my off period will be half contribution, my on period of the pulse will be half contribution. Okay, so I have completed my code. Let me start simulation. So can you visualize the rotation of the motor? So it's getting from 0 degree to it trying to come to 90 degree in a step-by-step manner, because my on period and off period are in equal contribution, and it will move like a step-by-step. Okay, because in like it will be having a field winding in like continuous phase manner. So each phase will be energized in step-by-step manner. So it's getting moving energized, and it coming to reach around 90 degree. So you can have the visualization. Okay, now in this, okay, now, so this is the working of servo motor. We shall stop this simulation, and now we are going to see one more interesting thing. So let me show you that first. So now I have explained how by using pulse width modulated signal on period, off period, your motor is making its rotation from 0 to 90 degree, 90 degree to 180 degree in a phase by phase manner, right? Now I am going to use potentiometer to vary the rotation of your servo motor. Okay, in that we will see how it works. So first let me take breadboard. Before that, let me delete this. I will take this one, because if see this one will be already your this is the predefined design available in our Tinkercad. If you see that this only the thing is 5-volt and ground has been correlated, that is wired with this breadboard. Now the thing is I'm going to use my potentiometer, right? See, this is my potentiometer. Okay, as I told you, now I'm going to connect my ground pin with this ground pin, because ground pin, why I'm going to connect with breadboard means here the Arduino has been interfaced with this breadboard top and bottom part. So rather than connecting with my Arduino, I'm going to connect it with my breadboard. Okay, so this power pin is I'm going to connect with my 5-volt power supply. See, this 5-volt red color is taken from this 5-volt Arduino pin, and my signal pin is connected to my second pin of my Arduino digital pin. So you can visualize it here. Or else as like we can connect it with my 9th pin, because this is a inbuilt pulse width modulated signal. Okay, next one, in potentiometer you will be having 3 terminals. In this 3 terminals of potentiometer, the first terminal should be always being grounded. Okay, so grounded means you connect with the ground pin. This is the wiper of the potentiometer is important, because for this wiper terminal we always be giving analog signal. Okay, so based on this thing, that is the wiper signal only, the resistor rate of this potentiometer will be adjusted. Okay, and based on this adjustment your servo motor will run. Because for this analog signal I'm going to take my A0, that is the analog pin of Arduino is connected with the wiper terminal of the potentiometer. For this potentiometer I'm going to fix 1 kilo ohm rate. My total potentiometer resistance ranges I fixed as 1, or you can fix it as 10 kilo ohm likewise. Okay, next the third terminal pin, you can connect it with the power supply. Okay, so red color power supply. So now we have been completed our interfacing. See, the thing is power supply ground. For wiper terminal of potentiometer we have given the analog pin of Arduino, and for servo motor same, the power and ground has been connected to the Arduino 5 volt and ground, and the supply signal terminal is given to the inbuilt, that is this approximate symbol pins are indicates it will give you a digital signal, but which are inbuilt pulse width modulated signal generated by this Arduino as by default, that is the 9th pin. In this, what is the most important interesting thing is, till now I have shown you the C++ programming for Arduino, but now I am going to use blocks plus text programming. Let me show you that. So this is not necessary, this is not related with our programming. Let me delete it. Okay, these are default schematics which is going to show. I'm going to delete it. Now I am going to create a variable, create variable. I'm going to give that as sensor value. Okay, I'm going to create two variable because I'm potentiometer as my sensor value. Next I'm going to create another one variable, that is output value. So my output value will be taken from the sensor value. Okay, so this is the thing. So first what I'm going to do means I am going to take this sensor value, I'm going to set my sensor value. What I'm going to set means, okay, the sensor value means I'm going to take potentiometer signal as my sensor value. So for potentiometer is connected with my analog pin, right? So I'm going to input channel where I can read my analog pin. I am going to fix this analog. Okay. Next, take again I'm going to come back my variable. There I am going to take my output value. So output value, okay. I'm going to take, so by creating a block over here, automatically the corresponding text will be generated over here. That is the best feature of this Tinkercad, where blocks and text programming we will be using. So by creating blocks over here with the concept of your interfacing, because you have been interfaced everything, so based on this interfacing and pin configuration only you are going to create block over here. So based on the blocks the codes will be generated or it will be realigned based on this concept. Okay, now I have taken the output value. Normally the potentiometer range is from 0 to 1023, but my servo motor rotation is from 0 to 180 degree. I should want to match this 0 to 1023 of potentiometer, that is my because I have fixed 10 kilo ohm. 10 kilo ohm means you will be having like a 1000 ohm rate. Okay, 1 kilo ohm rate, that is 1 kilo ohm means 1000 ohm. 1000 ohm means I am going to map 0 to 180 degree rotation with this resistance value of 1 to 1000 ohm. By making your adjustment, that is by making your wiper to adjust from 0 to 1000 ohm, your servo motor will make its rotation from 0 to 180 degree, that is mapping. So I'm going to map my output value. So for that I'm going to use math function map. So I'm going to take this map and I'm going to fix this map value. Why means I have explained you why I want to map, because based on my, because here potentiometer serves as an input. Potentiometer takes an analog signal. Its range is from 0 to 1023. So based on this analog 0 to 1023, my servo motor should make a rotation from 0 to 180 degree. So see 0 to 180 degree rotation. So I'm going to map this sensor value, because I have connected my analog pin as A0 A0 pin of analog pin of my Arduino. So the sensor value has been fixed with the proper block. My output value is mapped from 0 to 180 degree, but here I should take the variable as sensor value, because potentiometer value is I have been configured as sensor value. So I am going to fix this. So my sensor value of potentiometer of 0 to 1023 will be mapped with 0 to 180 degree. So this is the thing. Next I have to take my, I have configured my sensor value and output value. Now I want to go to my uh, output channel. In output, because I have taken servo pin, servo motor. In that servo motor I have, see analog pin of A0 is connected with potentiometer. The servo motor pin is connected with 9, right? So code, the servo motor pin is I have connected with 9th pin, right? So initially it is in 0 degree. Okay. So we have completed everything. So based on this, see, automatically the code has been rearranged and realigned. See, shall we see? Because by using the blocks, it will take the library files, because we have used servo. It has taken a servo file, library file default. By using the blocks, it has been taken servo default library file, and it has taken sensor value, output value, which I have been created as a variable in void A0, because A0 is the analog pin connected to the potentiometer, is taken as an input. Okay. My angle of rotation of speed will be 9 rpm, 500 rpm, 2500 rpm. What here I'm going to do means sensor value will be equal to the analog value pin. Analog signal which is taken from the Arduino will act as an input. This analog value is from 0 to 1023. These 0 to 1023, because if it is 0 means my servo motor be in 0 degree. In this 1023, half means 500. If my sensor value, that is analog value, is in the range of 500, means my motor should be in the range of 90 degree. If I am giving you my potentiometer at a resistance of 1023, means it should be in a rotation of 180 degree. That is, it should have, my servo motor should have completed its rotation. 0 degree, 90 degree, 180 degree. Here 0 means 0. Here 500 means 90 degree. 1023 means 180 degree. So like this, I have completed my blocks I have created. So based on my blocks, automatically the code has been generated. So till now I have shown only you the how we have to write C++ code. But here I have shown you how to create blocks with the text as a code for this simulation. So let me hide this code and start our stimulation. So I have initialized the simulation. See, your servo motor is not running. I'm going to adjust my wiper. Let me give 1 more. So once again, I don't know why it's not running. Let me check it. So it should be given to ground, and I have given over here. This is the 9th pin. In the code, if there is any issue, it should have shown as error. No problem. So let me check with the potentiometer stop simulation. So I'm just calibrating it. Start simulation. Let me check the wiring by this is the so first we shall connect with ground. Second, we shall connect with power. Signal will be connected with my 9th pin. First terminal ground, second terminal analog, third terminal will be my 5 volt. Okay. Okay, start stimulation. So we shall, let me check once again the code. I have taken analog pin sensor value and output value, and I have been mapped to 1180 degree, 9th pin. Okay, variable output value. Okay, start simulation. Okay, now your potentiometer, if you adjust it, so based on it, it will start our rotation. Can you see it? So by adjusting your potentiometer, your motor is rotating. Can you able to see this?
Yes, doctor. Yeah, we can see it. Yeah.
Yes, sir. Thank you, sir. So this is the thing, how to make, by using the potentiometer, how we can make a servo motor to run. What I have done means, that is a simple error in the code. Why what I have been missed means in the servo rotate servo on pin, I have not given this mapped value because we have mapped our sensor value, that is potentiometer 0 to 1023 to 0 to 180 degree of rotation. I should have been given my rotate servo pin output pin is 9th one, which we connected with Arduino. To that I should have feeded this output value over here, but I have not given previously. That's why by adjusting the potentiometer, it has not run. So when I have taken this output value and I have fixed it as a, this is the final degree of rotation for my servo motor, it started to run. So this is the thing. The output value is equal to map, and again I have been configured my 9th pin as my output value. This is the simple concept. Taken sensor value that will be mapped with my output. That output value is mapped with the servo pin which I connected with the Arduino 9th pin. Okay. So this I have been fixed. Let me see once again the simulation. So I'm adjusting my potentiometer, wiper terminal, it's rotating. So I stopped it, it has been stopped. So again I am adjusting my potentiometer, resistance value, it's getting rotating likewise. So this one and this one and this one, clockwise and anti-clockwise, clockwise, anti-clockwise. So this is the thing. So last topic will be our stepper motor. So stepper motor is simply, by the name itself you can understand, it is mainly used for rotation in step-by-step manner. Okay, your stepper motor is in one type of DC motor that moves in a discrete step. As I have told you, this stepper motor has main component of two parts, stator and rotor. Where this stepper motor will be specifically used means, I have told you, servo motor means the feedback will be as a mandatory thing. But wherever the same performance of servo motor is needed, but without feedback means this stepper motor will be used, because your stepper motor will be moving in a step-by-step manner. So you can achieve your target position by giving the steps without any feedback. So until you are giving a desired input as signal to your stepper motor, you can attain your target value. Okay. So there will not be any control circuit to make the comparison of your present input and present output to get the required output. Okay. So normally the stepper motor uses the concept of motor shaft rotation in a precise manner, where you will be giving electricity as in the form of pulses. Pulses means digital pulse with modulated signals, that is with on and off period. Where the stepper motor will be mainly preferably used means hard disk drives, robotics, antennas, telescopes, and in some toys these stepper motors will be used. But the one disadvantage of your stepper motor means it will not run at high speed, because you are going to give an electrical signal in the form of pulses. So you will be having high torque, but the speed cannot be attained, because speed and torque are inversely proportional. So if in the stepper motor you cannot attain high speed, but the torque can be high. That is the main characteristics of the stepper motor. Ma'am, you are giving electricity in the form of concept is called, because giving electricity in the form of pulse for stepper motor is nowadays called as a name micro stepping. Micro stepping means you will be giving variable controlled current to the coils in the form of sine waves. So like this. These are A, B, B dash are magnets. Okay, this is the normal DC motor. I'm going to take DC motor with the encoder, which serves as an stepper motor for this application. So my battery, and now I am going to take my breadboard. So I'm going to take and keep my breadboard. The other important thing I would like to tell you that so important thing is L293D. It is an motor drive because I have told you in real time you will not connect DC motor directly with your Arduino because your DC motor in a need of 9 volt for its performance or for its functioning, but your Arduino will be generating only 5 volt as maximum, so that this line driver will be used. What is this line driver means? It is a chip which is used to take low current signal from an Arduino, convert it to high current, which is required for your DC motor for its functioning. Since it is a simulation, if you are connecting directly DC motor with Arduino, it shows the visualization of running. But in real time, if you connect directly with your Arduino, your motors will not run. You should mandatorily use L293D chip, which are called as a motor drive. It is a 16-pin drive that will be interfaced between your Arduino and your motor. So this L293 will do what means it will take a 5 volt power supply from your Arduino and convert into a high powered current signal, which will be given to your motor for performance. So if in the step, ma'am, I can't clearly understand steps. If you want to make your stepper motor to complete one complete rotation, that is from 0 degree to 360 degree, means you should give 200 steps. Okay, 200 steps means for each step your stepper motor will move 1.8 degree. Likewise, if you are giving 200 steps means it's 360 degree. One way 270 degree, two way 360 degree. From 0 360 degree only we will call it as a complete rotation. So for stepper motor to get complete rotation, you should give the digital electrical pulse with 200 steps. 200 steps means for each step when it is received by your stepper motor, it will move 1.8 degree. So, ma'am, normally you told for motor control, you will be using pulse width modulation. So, I have told you pulse width modulation is for controlling your speed of your motor. But this line drive, this concept of giving digital pulses through line drive is H-bridge concept is to reverse the direction of your DC motor. If it is rotating in clockwise direction, if you want to make it to rotate in anti-clockwise direction, you can change the current polarity you are giving to that current polarity will be changed by using this H bridge concept. That is the thing, nothing but. So so this is the last thing. So we will see. I have taken it. Now what I'm going to do means I'm going to connect my motor negative to the power supply. Next, I'm going to connect my motor positive with my battery positive terminal. I'm going to take my 5 volt over here, and I am going to ground my channel over here. Here I am having encoder power. This encoder power is given with my 2 volt signal. Here you will be giving encoder ground that will be given over here. For channel A will be given with my 5 volt power supply, and channel A is given over with again 5 volt power supply. So I have interfaced everything. Now I am going to code it. I am going to use text. So here I am going to use my 2 pin as a encoder power. So based on my digital signal, that is, sorry, I should connect it with D3. Oh, sorry, escape. Let me hide this code. Escape. So because the inbuilt signal which is generated by Arduino in third pin will be given to this encoder power pin of my DC motor. So I'm going to configure 3 as output pin. So 3 high, 3 low based on this digital signal received by encoder of my motor. My stepper motor will start its rotation. See, 11 RPM, my motor is running. So if I want to increase my RPM, I'm fixing it as, okay, now you can visualize in a high perspective manner. It's rotating in a faster manner. See, 1139. So based on the encoder power signal given to my encoder power, encoder means I have told you, stepper motor means the electrical signal which you have been given will be taken as the positive cycle digital form of sine wave with a micro stepping process. That micro stepping process will be done by encoder because it will convert analog signal into digital signals in the forms of ones and zeros. So based on that, your stepper meter will makes it rotate. So thank you, sir. Thank you so much for this giving me an opportunity for presenting my Arduino fundamentals and coding knowledge with the students and with you with various countries. Thank you so much. Thank you, sir. So is there any, okay, sir, is there any queries regarding stepper motor, servo motor and DC motor which I have shown you today using Tinkercad software, online software? This you can use, you can go to Google and you can type Tinkercad and log in with your Google Gmail. You can use it directly within 2 or 3 minutes process. You need not necessary to download this software. It is an online simulation software, and I have shown you simple experimentation tab, programmings and simulations. And okay, sir. Thank you, sir. Thank you so much. Yes, sir. It is an open source software. You can use it wherever you want. Okay, sir. I think. Okay, sir. Okay, sir. So that only so application specific. I have shown a few demos, sir, like a PES sensor, object detection, and using potentiometer, how you can control the servo motor functioning and everything. So I think
Okay,
my students have.
Doctor,
Yes,
sorry,
sir.
yeah. I just want to ask you, how do you see the importance of power electronics uh, with, with what you presented? Because we could see that most of the things that you were talking about, actually, they are power electronics. I don't know if you can give us some comment on this.
Sir, I have given the explanation not with the perspective of power electronics, sir. But while showing them the simulation and everything, I just thought to show. I just want the peoples to understand other technical things associated with that servo motor and stepper motor and DC motor, sir. So that's why I have to, because we are going to handle the session for 1.5 hours. Within that, what are the important thing they have to know and important technical
Yeah,
terms they should aware of while processing or while they were doing experimentation with DC motor, servo motor, and stepper motor, sir. And they should know the what are the inbuilt performance or characteristics of each motors.
yeah. Thank you.
Because
Thank
I
you.
have not
Yeah,
elaborated everything, sir.
yeah,
But
of
I
course.
have given a shower point to everyone. So
Yeah,
whoever
yeah,
attended
yeah,
this
yeah,
session will be aware of these few things which will help them in some point of their academic life.
yeah, yeah, yeah. Thank you. Thank you very much.
Okay, sir.
Yeah. I just want to say something as well, for our students in
Okay, sir.
mechatronics. Yeah, in mechatronics, actually, this will be mainly the job of the engineers. The motors, whether it's a process control in a factory, or like access control system, or many other applications. Usually, we as mechatronic engineers, we come across these things, the things that Dr. Priyanka today presented. And really, there are other, of course, there are other actuators, like linear motors, or
Yes, sir. Yes, sir.
yeah, we have the brushless DC motors as well. They are
Yes,
mainly
sir.
used,
Synchronous motor,
nowadays.
reluctance
Yeah,
motor. Yes, sir.
yes. So mainly, the role of the mechatronic engineers, they should know how to provide the signal, suitable signal, to control the process. This process could be, like the speed, controlling the speed, or controlling the position, or controlling other things, like
Yes, sir.
acceleration. Yeah.
Yes,
So
sir.
it's really is very important for our students or researchers as well, to understand this issue, because this is mainly the role of the mechatronic engineers. Yeah, and thank you very much. Cheers.
Yes, sir. Thank you, sir. So that only I have today shown how the speed and rotation, that is clockwise and anti-clockwise direction of the motor can be controlled, and how while detecting object, how your motor starts it functioning, and its on and off states get varied and everything. And I have shown you, sir. So how to control the speed of the servo motor by adjusting the potentiometer resistance value, everything, sir. So that's it, sir.
Yeah.
And once again, I would like to thank Exrin sir for giving me this opportunity. Thank you, sir. Thank you so much.
No, you're welcome. You've been great, really, to have you, in this workshop, during this webinar. Yeah,
Okay, sir.
what you presented been very beneficial, and we thank you once again.
Okay, sir. Thank you, sir. Thank you so much.
Um, yeah. I don't know if we don't have anything else, we can terminate this session. And I would like to thank everybody who participated from different parts of the world, And once again, I would like to thank Dr. Priyanka, for joining us and for her presentation. Um, Thank you to you all, from different parts of the world. And we look forward, to see you in other occasions of similar type, hopefully. Okay. Thank you. Cheers.
Thanks.
Okay. Okay. Yeah. Okay. Thank you, Mr. Siva. Yeah. Yeah.
Thank
Yeah.
you, sir. Thank you so much.
Yeah. Thank you, Mr. Siva. Thank you uh, for hosting the yeah, for hosting us. Yeah. Thank you. Cheers. Cheers. Okay. Yeah. Okay then. From my side, I would say bye bye to everyone. Yeah, and thanks. And I look forward to see you once again, inshallah. Oh, yeah. Okay. Bye.
Thank you, sir. Thank you, sir. Thank you, Shivakumar, sir. Thank you for organizing, and thank you for the students for my sayings. You around 80 peoples you have been joined. I thought this will be very useful for you, and thanks for supporting me, guys. Really, I am very happy you would have joined and you will be in this meeting till completion. Thank you, guys. Thank you, sir. Thank you so much. Guys, kindly fill the feedback form. Okay.
Okay, sir. Thank you.
Thank you, Doctor.